Professor. For this essay, the net shape method I choose this time is metal injection molding to manufacture artificial hip joints composite. For this presentation, I will introduce this topic in depth from three aspects. The first one, background. As the aging rate of the elderly in the world accelerates, the elderly over the age of 65 suffer from various joint tissue diseases. The only way to solve the loss of joint function is to replace the failed joint structure through surgical implantation. So I researched on the method of metal injection molding to make artificial hip joints. Then I will introduce the process of manufacturing artificial hip joints by metal injection molding from the following 8 aspects. The first one component, artificial hip joints, is kind of biomedical metal material. This material has high specific strength, resistance to bending, fatigue strength, good processing performance, and not toxic. The second, the artificial hip joint is made of titanium alloys. Its abbreviation is Ti6Al4V, which alloys belongs to alpha plus beta alloy, and it is a two-phase material. During the deformation process, the strain and stress distribution in its constituent phase are very different. The third and the seventh points are combined to say about process described. The first step is the preparation of the injection material. First made into Ti6Al4V alloy powder by the method of 10% dehydrogenation and 19% gas atomization. Mix the titanium alloy powder with a bender. Put the mixed injection material into the injection machine and inject it into the shape of the hip joint. The next step is debonding. Involves several different stages, which is divided into solvent debonding and thermal debonding. The last step is sintering, which is heating at high temperature under vacuum or atmosphere so as to achieve final desiccation of the formed debonding blank. The next section is that using this method greatly improves the yield and fatigue strength of the product. Several reasons for the high mechanical and physical properties of metal injection molding products compared to the forging and casting methods. One is the density of the sintered part. The second is the injection process, injection pressure, temperature, time, and other factors affected. When design considerations, we should pay attention to the following points. The first one, the contact angle between the bender and the powered should be small. The second, choose a larger injection die. The third, the temperature, environmental, and other factors must be controlled well in the sintering stage. For the process economic, MIM can produce more complex shape and large batches of the metal parts. The products produced have good surface quality and low rejection rate. As for the last section, the alloying elements in the first raw material powder cannot meet the performance requirements for manufacturing artificial hip joints. Interstitial elements such as oxygen, carbon, nitrogen, and hydrogen have an adverse effect on the properties of titanium and titanium alloys. Then the part 3, summarized and prospect of the artificial hip joint. The manufacture of artificial hip joints is very important to the future of mankind. With the rapid development of the science and technology, I think the net shaping technology will develop better and better, allowing people to have more choices in artificially manufactured hip joints, teeth, and other organs. Well, the last slide, this is the relevant literature for this course I found. In shortly, through this course, I have a better understanding of the principles and advantages of net shape technologies. So thank you, Professor. That finished.